Hello and welcome again. Welcome to stream number 7. Today we'll try to do some actual coding, actual project setup. As always, feel free to like, subscribe, follow on Twitch, ask questions in chat or maybe suggestions. Also, feel free to leave comments after the stream is posted on YouTube. And on YouTube also, the stream later will be chopped up into smaller, a little bit more digestible videos where I skip all the pauses. If you prefer to view it in a little bit shorter way, in shorter format. So that's all when it comes to all those boring announcements. Let's talk about what we'll be doing today. The thumbnail suggests that today we'll be working on the abstraction and real FS. So last stream, we were done with all the tutorials, and we started exploring the idea of making that library for dealing with file systems, but in a more abstracted way, just to have a wrapper over how you interact with files and whatnot, so that we can replace the actual implementation with either the one that interacts with real file system, or maybe with one that pretends to be a file system. It's all in memory, which will be great for testing. That's how I want to use it. Or maybe something that deals with FTP or Samba or with S3 bucket, And we want to do it so that we have a main library that's like the main abstraction. That's like a base that specifies how we can interact with the library, and I can probably visualize a little bit better if I'll share my screen. By the way, I'm trying to stream in 1440p this time, so maybe the text will be a little bit crisper. I hope so. So basically the idea is that we have our application, and it can interact with the this core abstraction library that provides all the ways that we can create a file, delete file, check if directory exists, or maybe read from it, write to it. All those basics commands will be defined by our little library that just provides the abstraction layer. It doesn't provide any actual implementations. And then we would have separate libraries to download or install or whatever that actually provide the implementation, that you just ask, hey, create me a new real file system, and we'll just return the file system. We'll return an instance of that abstraction that we have that we can query and do things with, while really behind the scenes we'll be using the standard library to deal with files. Or in memory we'll do something vastly different, even though we're interacting with it in exactly the same way. And this way we would be able to easily write an application that, does something with files, no matter if they're in memory, if they're in real file system, or on S3 bucket, or whatever else somebody will implement. Because the idea is that making the abstraction layer a separate library, we can make it that, for this library, this one is dependency and nothing else. Therefore, it will be easy for anyone to just, hey, I'm going to make my own library. I'm going to make my own implementation of it. And, go for it. that kind of approach. We want to make it open. So let me check our chats if there's somebody there already. And nobody so far. All right. I'll pretend I'm talking to somebody. As always. All right. So I reached out on Discord. On Discord, there's a server for like the official NIM server. And I reached out and asked around, hey, I want to make a library like that. I want to roughly, organize it in such way. What feature should I use? Because last time on stream we were looking like, okay, we could do it through inheritance. We have base object, which is this, file system or file or whatnot. And it could provide the methods that could be then overridden by the actual implementations. And that's like the classic OOP approach to solve the problem. And in this case, I think it will be quite viable because it's really simple. There shouldn't be more than, it should be only, okay, this is the base object, this is the implementation, and that's where it ends. At least that's the idea, right? Because we're not expecting to create whole hierarchy or whatever, some crazy stuff. It's just something really simple. And again, only a limited number of commands or whatever, the things that you can do with file system. So from that perspective, it's something relatively simple and should work real, well, not be, over-engineered or anything. And then we also tried to look at concepts, another experimental feature of NIM, but initially it looked a little bit like interfaces, which was like, that could be good here because all we really need is a bunch of interfaces. But no, sadly, doesn't seem as if NIM had something like interfaces, which is a little bit sad, but I guess we'll live with it. We can just make a base object with implementations that simply throw, and NIM will be raise an exception whenever there's something wrong. So, something of that sort shouldn't be too complicated. But there were two other things that some people recommended. So let's go to Google and type in NIM signals, or like STD signals. Not nuclear instrumentation module. That's not what I'm interested in. Let's go to NIM standard library, okay? And somebody pointed me that the streams standard library has some kind of different approach. If we can find it, there's for sure lots of libraries. Streams, a stream interface, and two implementation thereof. The file stream and the string stream, which implement the stream interface for NIM file objects. Look at that, and strings. Other modules may provide other implementations for the standard stream interface. So there we go, it's some kind of interface, which is exciting. So what do we have here? Basic usage is open input stream, read or write stream, close stream. So we have string stream example. So we import the streams. We can create a new string stream. And I guess we can just provide it the value, okay? In this case. And we have a line, and while stream.readLine, I guess this is target to where to we want to specify. I would expect that readLine expects a var string, and we just echo it, and that should allow us to go through it. So it looks like that stream allows us to read a line or something like that, and probably have some other things available. And file stream is similar. We just create a new stream by new file stream, give it the file path that suggests that we want to write to it. And of course, if we manage to, if it's not nil, as in we actually created the stream, then we write those 3 lines and close it. Okay, this is simple to use. We can read from the file, blah, blah, blah. And let's look at that. It provides a file stream type, which is referenced to a file stream object. Okay, a stream that encapsulates a file. File stream object, a file stream object, okay. And it's an object of stream. So I guess we have some inheritance here. Okay, so file stream is just a reference to the file stream object, okay. So that's interesting because sometimes we saw that something is, a name, and then we add a postfix ref to signify as a reference. But I guess if that's the most common version to use it, we just leave it this way and mark the actual object instead of reference with the obj postfix to say, hey, this is the object. Okay, I see it. I see how it goes. Then we have stream, which is a reference to stream object. Oh, and stream object is the base class. Look at that. And we have all those things: close implementation, add end implementation, set position implementation. Okay, so these are all the implementations, right? Okay, that makes sense. So nim call. We need to look at that source code because this might be interesting. Because basically this base object, stream object, defines by a bunch of procedures. Like close implementation, and it's a procedure on the stream. It's interesting, it's not on a stream object. It's on a stream which is defined as this. That's interesting. Maybe it's a simple concept, I'm just not familiar with it. And we have a lot of those, and they have like nimcall, which is interesting, what errors it raises, and that it's GC safe, garbage collection safe. So all of them have nimcall. That's interesting. I need to look at what it does. So supports writing or reading. And then we have, also the string stream and some other stuff. And then we have something like close, right? And we do it on the stream. And it doesn't have anything special here other than forbids, which would be what's forbidden within it, but it's not a big deal, so we can close the stream. But didn't the stream had something similar? Close implementation. So it feels like those procedures here are just like a placeholders. Nim called for calls something like close. Interesting. How can we get to the source of it? Source lib pure streams nim. There we go. Got the source of the library. That's handy to have here. Let's see. Only 1500 lines. We have our definition here. So let's look. We have the stream, which is defined as a reference to stream object. Here we have the stream object, which is the object, like a base class, because it's an object, it inherits from the root object. Note, that these fields here shouldn't be used directly. They're accessible so that a stream implementation can override them. Okay. So we basically define those. Oh, I see. So these are like fields because we define an object, and on that object, usually you declare all the fields. All the procs are done later, right? Like here and here, not within. Look at the indentation. We have, like no indentation here. While all those are indented, they are part of the stream object definition. So these are just fields that can hold a procedure that takes the stream. Okay, in this case, doesn't return anything. It just uses this nym call, which is very interesting. We'll need to look it up, but in a second. So these are kind of like little placeholders where we can put all the implementations in, and then we have, I don't know, like flush, and it does stuff. Do assert before write and all that. This is like a okay. We ignore that. Close. Oh, so these are just runnable examples. Okay. So that's how it should work. Well, really is if not is nil flush implementation. So if the flush implementation is defined on a stream, then we just call it. Okay, that is really simple. And the same thing with close. If the close is defined, we just call the implementation. And that's how we go. So if we continue with all that stuff, peak data, write data, there's a lot defined here. So let's see if we get to something more interesting, which is not just a procedure, but an actual implementation, because that would be more interesting, like, the file stream implementation. We keep going. Ah, what was it? New string stream. And we have owned string stream. That's different. We haven't seen owned yet. And this is at compile time. So we basically have new results. So basically reset the result. This might be from older implementations. And we say data, and we give it we specify the close implementation, at end implementation, set position implementation, read data implementation. So we just provide all those implementations here. And yeah, and we return an owned string stream. This owned is the second thing that we need to check. Let me write those down quickly. Owned, and the other one was the nym call. Okay, those are the two things we need to check. Okay, we did that. Well, read all should be just utilizing the read data and normal stuff. Okay, that makes sense. So when the major, minor is this and that, we define that, for example, SS, I guess the string stream, read data string. That's the definition, right? Again, it's compile time. So, okay. And then we define, we create a new string stream. Okay. Oh, we create a new string stream out of the stream. Okay. So we, I guess we can specify that. There's some kind of constructor that we can specify maybe. And then we do the actual reading and just return the result. Okay. That's normal. The same thing here. The close is just set data to nothing. Okay. Makes sense. And the new one is just all that. So where do we define the string stream? String stream was the reference of string object, which was this, that just holds the data. Oh, it's a stream object. Okay. Okay. What's the data and position? Okay, makes sense. I don't know, is it overcomplicated? It seems like it's kind of overcomplicated. But at the same time, if we look at new string stream, right? We provided with 1, 2, 3, 4, 5 implementations. With 5 of them. Well, if we'll go to the actual stream defined up there, lots of scrolling. Here we have defined 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different possible implementations. So we'll default the new file stream, okay? Where is the new file stream being defined? Here. We have the new file stream. This is just an example. We don't care about that. And this one defines 10 of them. Okay, so I see what is happening here. So, so what it means is that the stream object, okay, so the stream object allows us to define those specific implementations and hold them, right? Those procedures. So that for a specific type, we just shove them there and we can use them because this uses the fs close implementation, fs at and, etc., etc. And let's say get set position or something. If we can find it somewhere here. Procedure set position, it's set file position. And let's find that one. Oh, that's the only one available. I guess this might be defined somewhere else, the set file position. And we'll give it the stream itself. Okay, so basically the stream, the pure stream object, it allows us to attach various implementations of specific operations. And then what happens is that the specific implementation, like the file stream, can attach its own implementations of those methods. It can pick and choose which it actually needs to implement. And then those implementations then can call on the stream itself, hey, I need to call the flush, and it doesn't need to know about this specific flush here, right? It can just call whatever's attached to it. So we have we can compose the whole object out of those little procedures, which is interesting. I'm just trying to think if there will be a need for that. Because in our case, we actually want the user to have the same way to interact with everything. We don't want them to have a different way of interacting, with in memory stream versus different way of interacting with a real file system, right? We want exactly this. We want it to be exactly the same. Unlike here, where file stream is different than the string stream, because with file you need to open and close it and do other stuff. So yeah, I don't think this will be worth it. This will be just overcomplicating it. I don't think we need exactly that. Okay. We learned something though. This is fun approach. So now let's think about let's take a look at the other thing that I was suggested to look at. Let's go to nimlang. Okay. And we should be able to go to documentation, and there should be the Nimble package directory. And let's look for a package called Traitor. There we go. Trait-like package made without insight. So what I heard about it is that it's a little bit of similar approach like what we just saw with streams, but a little bit faster, I guess. It doesn't do specific things. Traitor allows one to use tuples to describe interfaces that can ensure types implement procedures for runtime dispatch. The trait tuple must be a distinct tuple. All procedures must have atom appearing only once as the first argument. All trait procedures should be annotated with their appropriate calling convention, as nym defaults to closure. For types, you must annotate with nymcall. Okay, so nymcall is so that we can just specify closures. Okay, so we have an example here. We import Traitor, we specify type clickable, which is distinct tuple. So always use distinct tuple interface to make it clean and calls the implement trait, and because implement trait requires it. Okay, so this clickable has over, which is that kind of procedure. Notice we use atom as the first parameter, and it's always the only atom. Okay, so we just specify some random atom thing, and what do we need here? Then we have onClick, again, something that will be called and return a string. Okay, that's clickable. Then we have unimplemented trait. So something overloaded, we can add overloads by using a tuple of procs. Overloaded. Oh, as in, yeah, we have those two variants. Okay. And therefore we can specify there's a button, object, radio, which is also object, and implement trait clickable. Okay. What does it do? And then we specify over and on click for the button and for the radio. I guess this is like maybe a, what do you call it? Macro that somehow detects further procedures that are being defined. Okay, I don't think this is also a good solution for us, because this probably would be great if it's within our project and we're just using it to achieve something, right? It's within our project. We decided, okay, this is nice to use. We'll use it often or whatnot. And it's on us to learn it and use it. But if I would make a library that forces everyone to write implementation in this fashion, I presume not everyone will be happy. Okay, but nonetheless, this is very interesting. Very interesting approach. It shows you how you can solve problems differently in NIM. So I guess we're gonna get back to the basic idea of just having an object that is like the base class that has implementations that just throw errors, and then ask every concrete implementation of that abstraction to implement them. Let me get to the code editor and maybe we can try something temporary, okay? We're here, so let me switch back to the Visual Studio code. We have our old stuff and let's ignore it. Let's go here. We have some random files that we can delete. Yes, delete. We don't need those things. Okay. Let's create a new file and let's call it file system abstraction. Okay, let's do like a test of writing it just here in place without setting up everything yet. So let's say that we define that we have a type and let's call it file system. And that will be object of ref, root ref, I presume. Was it that? Root object. Whatever root ref is. Okay, so this will be our file system. But that's a file system as an actual implementation. We probably want to pass it on as a reference, right? So can I do ref object of root object? Well, let's call it file system obj. And then we'll also do type file system, which will be ref file system obj. Come on, file system obj. So look at that. It isn't happy because we need to specify it here. So I don't know why in the other file we were able to just have them in the other order. But oh well. So now let's define what's available in our file system object. I guess because it's an interface, we don't really want to worry about what we're specifying, what's being held inside the object itself. So we can just straight up ignore that. What we really want is to be able to specify actions that can be called on the file system. So let's say that we define method, and that will be, I don't know, check file, or check if file exists. Okay, something very descriptive for now. I don't know what the good approach is here when working in NIM. So check if file exists. This will be publicly available. Okay. And it takes the self as a file system. Need to remember about the colons. And then we do file path, which will be string. Okay. That's how we interact, that we just provide a string. Later, maybe we'll be able to change string into some kind of file path. I think nim has some kind of separate module for dealing with file paths. So that's that. And we need to specify that this is a base, right? It's not a requirement, equals, and right now it's really unhappy. Method is not a base. It will be a base. We just need to raise new exception. And I wonder what exceptions are available. Error. Key error, field error. Library error. Is there like not implemented error? Because that will be perfect for me, but I don't see it. So right now, let's say that, hey, this is library error. The library didn't implement it. We do check if file exists, hasn't been implemented. Let's call it method name hasn't been implemented. And we save it. That should be good. Again, it complains. Method is not a base. How is it not? We need to specify that it returns bool. Okay. Do we put it here? Nope. Where on earth do we put it? We do all that. Okay. And return type, we specify that it's a base, and we just do that. Something isn't working here. I'll restart it. Let's restart it. I think this whole nim suggest just keeps breaking. That's too bad. I hope it's gonna improve over time. And now no errors. Okay, so we have that. Let's add maybe one more. Something like check if directory exists. The dir path. And we just specify it here. Save. That's it. Okay. Oh, I see where the problem is. I think I know. So we specify those methods on the file system rather than file system object, which is the offroot object. So I guess, could I do something like this? Reference object, offroot object, and just get rid of this and make it just like that. Save. Nope, still complaining. Don't know why. Yeah, ref object of root object, right? Method, name, all that. String, and we say it's base. So if I'll just paste it here, got the same thing. This, that, self, file system, path. Yeah, that's better. Let's call it just path in both. And return the type and specify it's a base. So I really don't know what the problem is here. Let's assume it works, okay? And that should be it. That should be our file system overall, the thing that we will be implementing somewhere. So let's create a new file. Let's call it real file system nim. And let's specify here that we do import. And how do you do it here? Dots or just file system abstraction? Okay, so it imported it, just isn't showing. So I should be able to make type real fs as in for real file system, and that will be object of file system. Right? I guess we need to add a star here, asterisk, to export it. Will it work now? Yes, now it works. Look at that. Ref object of file system, let's call it that way. Oh, now it's undefined. And how do you import between files? We had it somewhere in the basic. We did it in the basic NIM tutorial, right? nimlang.org documentation, and that was learn NIM in 5 minutes. No, that wasn't it. Basics tutorial. Modules. We have those. Importing a module, import this, and creating our own. We created it. You can import one from the other as a module. So we have this, import first file. Yeah, just that's it. Just import the first file, and we should be able to use it. File system abstraction. Let's declare button used, and suddenly undeclared identifier file system. Ay. Let's continue. Let's just do method, and we can just copy those two and just return true or false or whatever. And it will be self as realfs, right? They won't be base anymore because this is the actual implementation. And I know he'll be return true, while here will be return false. Just whatever right now. So when I save it, it's being used and everything. The only thing I would need to do is also add procedure, and what would we call it? New real file system, right? We just provide it with this, and it should return a file system. Okay, and that will just do return new file system. I don't remember how new was supposed to be used. Do we have it somewhere here? Get file, new file, return real fs, just like that. So not even new, just file system. We save it. Routine file system unknown. Why? Okay, this is a little bit troublesome. Suddenly I can't import something. We for sure export it. It's being exported here. Okay. And let's just make sure that tutorial shows it the same way. I mean, the tutorial doesn't show exporting of types. It just exports the procedures. Let's ask Claude, how do I export a type in NIM? And then how can I import it in another file? Both files are in the same directory. Let's see if it returns something coherent that's actually true for a change. So yeah, we specify exactly with a star. And then import it. And that's it. We have person name, so we just import person. Type person asterisk equals, and then you have the object thing. Something tells me nim suggest is just freaking out here for no reason. We have our abstraction, a type, we can even do this whole fancy thing. That's the file system, right? All good. And here, we import it. Now we don't get any errors. Oh, now we get errors. Expression result has no type. Okay. So let's do that. And how do I write a proc that returns an instance of the following type? Okay. Return time and use new keyword. Exactly. So we need to use that new. Oh, new is the action method. So let's do it new and just call it that way. Everything's wrong here. Ay, ay, ay. Result has no type. Everything is wrong. So now in hello, I'm gonna comment it out as well because we don't need all that. Let's just go to the bottom and we'll do import file system abstraction and import real file system. Okay. So we can do var fs is new file system or new real fs. I should be able to call it, right? Or did I forget to export it? I forgot to export it, of course. Save it again. So now it works. Type is error type, of course. Now you should do fs dot check if directory exists. And we just give it some path because it doesn't matter right now. So let's do let if product exists. Okay, and echo it exists. And we'll give it the exists. So at this point, we shouldn't get an error when we run it, right? Because it should be implemented. If I run it, there's an error. Method check if there exists hasn't been implemented. So new realfs returned it, and the only thing is that we didn't return the proper one. We want to return realfs instead. Okay. So let's run it again. And now it works. It's just shows errors everywhere, which absolutely sucks. Let's run again. Okay, so the code works. It just no suggest sucks. So let's try it differently. Maybe because we're supposed to use the newer nim extension for VS Code, so I guess we'll use it. But okay, the first thing works. When we got the new realfs, we got the proper file system, and we were able to call if the directory exists. So what if I'm going to get this real file system and create a copy of it? We'll call it in memory file system. We'll just paste everything and let's just rename this into in memory fs. Again, everything is fine. Return just the new in memory fs, and our implementation will just be, let's make it like this. The real file as fs will return that everything exists true, while the other one will be returning false. So what it means is that I should be able in our hello also import in memory file system. And the only thing, so if I save it, in memory file system. Oh, we need to make it .nim. Okay. Let's try to run it just to have a baseline, because right now it's using new real file system. Okay. And what it means, it returns true. But if we'll go with new in memory, right, and we'll run again, returns false. So from the user perspective, this is always the same because we're calling from the main abstraction, and only but the implementation behind the scenes changes. So this is good. It's just for some reason the whole highlighting what is what just freaks out completely. But I guess we can't do anything about it right now because, hey, that's NIM at this point. We don't have everything implemented correctly yet, so too bad. Okay, that's progress. That is progress, I'd say. We know that we can do it. So I guess we need to figure out how to set up those actual separate libraries. So let's look it up. Let's try to figure out how to create an actual package. Publisher package. Wow, this is large text. This is central listing of all packages. Okay. Adding your own package. So add your own package. Fork this repository. Edit packages JSON and make a pull request. Package JSON is a simple array of objects. Each package object should have the following fields unless the field name, URL, where we can retrieve the package, method should be used to retrieve the package. Currently get and HG is support, whatever HG is. Tags, description. Okay, so we basically have our, description of the package. So let's look at some. Packages JSON. This would be long, right? Yeah, this is long. A long file. So what were we looking today at? We were looking at traitor. There we go. So it just points to a GitHub repository, okay? And that's it. So let's go to the repository and see how that library is being, how it's been made. So we just have our normal stuff here. So we have getignore, we have readme, traitor.nim, and nimble. So let's look at the nimble file because I guess that's like package JSON. Specify the package, the version number, author, description, license, source directory, okay. And requires specification of nim and micros. That's interesting. And task requires test and balls. Okay. Okay. Interesting. So, okay, that's simple enough. What is traitor.nim? Is that the whole implementation of the whole library? Looks like it. Yes, that's a nim code. Okay. So in trader.nim in Nimble, do we have some kind of method which file is most important? No. Okay. So we have trader.nim, and then in here we have streams. Basic standard / streams like API built using Trader instead of OOP. Okay. So this is just an example. Okay. And that's it. That's all there is here. We have tests. Okay. Benchmarks. And just the workflows for GitHub. Okay, that is simple. So let me just check something, because we have all those types here, and it's called trader.nim, just like the whole thing is named here. So we could basically have the same thing. And if we go back to the whole long file where we can search for trader, we have method, tags, description, license, web. This doesn't even specify what the actual entry point is. It just, hey, this is the URL. And I guess because the whole thing is named trader in both places, it's just gonna figure it out that, hey, it's trader.nim that I need to run. So we'd need to figure out the name of the package, I presume. And this way we would we'll be able to reserve our spot and name things. I guess it's not that important right now, but hey, it's a start. So what if for now we would start implementing it as in a single place, just so that we can test it easily, and then we could export each directory as a separate library or something? Let's just get back to code and figure something out. So instead of having those all those separate files, let's make folders for them. Let's call it what could we call it? It's a good question. Our library, because we'll be dealing with file systems, so FS is recommended in the name. But at the same time, the library that I'll be inspired with is Go Afero, right? This library is what I'm inspired by. And it just has a random name, Afero. Yeah, file systems framework. YouTube's complaining about too low bitrate. I will need to double it. The problem is that if I'm streaming to Twitch, Twitch is unhappy with more bitrate. Maybe I'll fix it one day. For now, I need to stream to 2 sources with the same bitrate. Okay, so getting back to code, what could we name that library? UniFS? Universal file system. That's a little bit dumb. Oh, I hate naming. I mean, sometimes I like it, but in a situation like that, I'm just like clueless. Does somebody have any suggestions? Common FS. I'll go with that unless we'll have some really cool suggestion. So let's call it common fs, and in there we'll have the common fs.nym, and that will be our entry point. So we can grab the file system abstraction, grab everything from here, okay, and put it in common fs. We have our file system and our initial two little silly methods. And then we would create a new directory, which will be real fs. Sure. I'm sure there's no such package. Real fs. I'll have a new file, real fs.nym. And we'll just grab, this is to be deleted. Real file system, cut, and paste here. Import. Do I need to do it like this? Common fs. Doesn't like going back. Will that work? I don't think so. I don't know yet. We'll figure it out. Then we're gonna make one more folder, which will be in memory fs. And we create another file in memory fs.nym. And this way we can pretend that we have three separate libraries, right? Modules or something. I don't know how to call it properly, but in some places it's called library. In other places it's called a package. And I guess each file is considered a module. So again, common fs. That won't work. And then in our hello, we should be able to say, hey, I want to go common fs/common fs. Okay, it doesn't have problems with that. Then we do real fs/real fs. And this one will be in memory fs. Whoa. / in memory fs. We save it. And it shouldn't complain. The complaints can't open file common fs inside the real fs nym. Okay. Hello, the drunken alcoholic. Good content, mate. I have learned a lot from your series so far. As a beginner hobbyist programmer, learning nym. I'm glad you're learning. I'm learning too. So I just hope that I'm not saying too many things that are like absolutely wrong. Right now, I'm trying to figure out how to deal with those separate like modules or whatever. Because again, it wasn't really described well in the little tutorial. It was like the minimal possible example. So right now the compiler is complaining that inside the realfs.nym, they can't open the file common fs. So here we basically we try to import the common fs. So what if I'll try to do .. as in go backwards? Will the compiler work? No, it cannot. Oh, .. /common fs/common fs, because it's within that, right? We first go back, then go into the folder, and then into the actual file. So let's run it. Okay, now it works. We need to just do the same thing inside the memory fs. So let's copy it, go to in-memory file system, paste it here as well, and that should let us run it. Important not to use realfs. Oh yes, because in our hello, we're just using in-memory file system. But if we're gonna do the real fs, we'll complain about the other. Okay, we've got progress. It's just that nim suggest goes crazy. Everything is an error in there. All right. So now we just need to figure out what our interface should look like. So as comments, let's just hide this. We don't need that. As comments, I could write down list of things that we need to check out, right? So let's make a comment, and we need to check out basically what methods we need to provide to the application, to the library user. Okay. So basically the API of our library. For sure we need to provide how to check if the file exists, to, I don't know, get the file and open it, or maybe delete it, all those operations. But we need to specify exactly what we need to provide here. And then the other question is, what other methods could be provided to support other file systems? For example, FTP or Samba or S3 buckets, etc. Because they all FTP, Samba, and S3, they all deal with files, but at the same time, you can in some way interact with them a little bit different. So we will need to find a middle ground between, the typical operations of a typical file system and something that is already abstracted away to a high degree. Because with S3 bucket, I never worked with it directly, so I don't know. This terminology is maybe download. You don't read from it chunk by chunk. Maybe you need to download the whole file, or this or that or that. Most of it will be abstracted away in the actual implementation of our interface. But it would be nice if the methods that we're providing aren't just confusing the hell out of everyone that tries to use it. Because we have to assume that if this project works out and somebody implements the S3 bucket interface or whatever implementation for our interface, there will be people using it just solely to interact with S3, and they don't care about anything else. Might be that way, but we don't know. So these are the two things that we need to look into. And where can we look for those things to decide what we need? So first place to look, I would say, is the nim standard library. We should first look how nim already implements working with files and directories and overall file systems, how they implemented it, because this will point us to, how it's supposed to be, how everyone already who's familiar with nim, how they'd expect it to work and what methods to be provided. So that's first place. And then a second place that I'd say we can look is into Go's Afero library. This is library for the Go language. That is exactly what we're trying to do, which is basically a library that provides several implementations to interact with real file system and memory file system, the S3 bucket, and a bunch of other things. So we already have, somebody already went and did all that work of abstracting it away and making sure that it's easy to use. I used it myself and it was very pleasant to use. So yeah, that's another place to look at. So let's try to look at nim standard library. how they're interacting with files. I haven't checked that yet, so that's going to be new. Let's go away from here. Afero will leave for later. We have in basics. We could go probably to documentation. And let's look at the standard library. Okay. And let's see what's in our things. Pure libraries, automatic imports, basic procs and operators that every program needs. It also provides I/O facilities for reading and writing text and binary files. OS module, you're saying. Okay, we're gonna check that. So far we have the first hint at system, because I remember that in one of our tutorials, we were looking at the simple tutorial with writing and reading from files, and I believe we had things like open, close, and write, something like that, where we could operate on files. So let's see. This way we'll learn a little bit also how to go through the documentation. So we have, this is the module imports several separate modules, and their documentation is in separate files. We have iterators, exceptions, assertions, dollars, and C types. Dollars. Oh, okay, so I guess this implements all the operators for various types, right? For something dot magic type. If your language already specifies magic, that's great. Oh wow, okay, let's ignore that. We don't need about strings here. Strings and characters, sequences, sets, numbers, ordinals, miscellaneous, example, and do we have some like open? What does it show? Types. Does it show within system module? Yeah, we have open array. And everything's open array. Wow, 116 instances of open in space. Nope, that's not it. File name, that's stack trace, so that must have not been here. Okay. So that's not it. Not system. Let's continue forward. Maybe we'll find something more interesting. Atomics, bit operations, compile settings, CPU info, effect trace, onions, locks, macro cache, macros to collect compile time information. Oh, across modules. Interesting. Macros, rlocks, type info, type traits, volatile. Okay, algorithms, collections, string handling, time handling, generic operating system services. There we go. That's something that sounds a bit more like OS module. App directories, helpers for determining special directories used by apps. Okay, let's just check what they return. Do they just return strings? No, they return path. Get cache directory, and it returns a path. Get cache directory returns a path. Configuration everything returns a path. And path is distinct string. Okay, so it's just a string just made as a path and has defined various procedures where we can, I guess, concatenate paths with slashes. Oh, we can just traverse like that. Ah, that is really fun operator. Huh. Compare, get absolute path. Okay, so these are, we can easily specify things. So let's actually already make some adjustments to our, so this is standard paths. Okay, so I guess we need to get that into our project, and in CommonFS, we're gonna import it, standard paths, and whenever we need to provide a path, we say that it's a path instead, okay? This way, we're making sure that, you know, this works as it's supposed to. So let's make that import in both other places. I don't know what's the idiomatic way of importing in nim, but I'd presume that standard imports will be first, and then all the other imports, like, you know, more local modules or some other libraries that are not the standard library, will be after that. So that's how Go organizes things. That's how we organize things in C#. You know, we just have 2 imports, but already it could be useful. And we did the same thing here. We just need to make sure that it's a path. Okay, save that, and then the last one will be in memory file system, and we specify both to be a path. And what it means now is that, let's get rid of those other remnants of files, delete, there we go. In our hello, we shouldn't be able to call this with, you know, check if directory exists with just some path. If we'll try to run it, I expect that we'll get errors. There we go, errors. Type mismatch, some path. And it's complaining about those 2. And it says that it should be one of those 3, either in-memory file system, real file system, or just file system. And all specified path will be provided a string. So we should be able to just do .path or .path. Save. Will that work? Undeclared field path. Okay, that didn't work. How do I create a path? Path and something of that sort. Run it. Oh, declared identifier path. Oh, duh. We need to actually import our path, right? And now run it. And now it works. So I should be able to just say that some path dot path, because, you know, it's nim, and it works. Okay. So this way, you know, rarely somebody will be using it as, oh, check if file directory exists and just shove the actual path here. You should get it from a configuration file, or maybe maybe something else from some other source. Maybe it's being actually you know, being built somewhere. So usually you would have somewhere that let path is I don't know, something, and then you would have that. So we could probably do something like the path is, let's get the root directory, okay? And this should be already as a path. And we should be able to do directory slash, or let's make it like, I don't know, user slash username slash, what else would that be? I know, managed directory, okay? So in the documentation, we already saw that we should be able to use this symbol to concatenate paths, but right now it's probably complaining because all these are strings instead of paths. So that means I will need to get every single one, and now it shouldn't be complaining, right? Now it works. But what if I'm actually gonna get rid of them? Will that work? Nope. It's unhappy. Too bad that we don't have an operator that just works on those. It would be so much easier to just, we can probably define proc. We have that symbol. We do head, and we specify that head is of path. And then we do tail is string. And we should return a path. And whoops, and that should be basically head slash tail dot path. Okay. And suddenly we should be able to just do that. Save, run. Now it works. Just in case, let's just do additional one that makes it the other way around. String. And this will be the path. Okay. And head.path and tail is this. Suddenly tells me defining those is kind of wrong, because the whole idea of the path is that we're not mixing it with strings. But right now, for those test purposes, I'd like to actually be able to just mock it up quickly. Yes, the Drunken Alcoholic says concatenate with the ampersand operator, but it's maybe just for strings. Yes, the ampersand is just for strings. If we would try to do it here, let's see what happens. We'll try to run it. Yeah, it's a little bit confused because I guess the ampersand isn't defined for paths. The whole idea is that you just use the slash, just as if you were working with path and path only, and don't mix in with strings. But I'm just doing a dirty thing here and just define those operators for mixing either path with string or string with path, and it should work out for us. And compiles, runs, so that's good. I really like that you can actually do that. It's just awesome. Okay, so that's that. And here, instead of using this, we could just specify that as a path, right? Run, bam, we'll give it a path. Everything else accepted the path. It works on a path, so there we go. So if we look at the path itself again, what's being available here, we have that slash that joins two directory names to one. So it returns normalized path concatenation, preserving whether or not tail has a trailing slash, or if tail is empty. So basically this is just to combine two paths together. This is very much fun to just get to the parent. And it also gets head and tail, the same as parent directory slash head slash tail. Unless there is no parent directory, then head slash tail is performed instead. Oh, so yeah, we basically get the parent. If we would use that, it would take the head, get to its parent first, and then attach the tail. Okay. It's interesting that that is implemented as its own operator, because it seems like something that wouldn't be that often used, but I guess it is. I guess it wouldn't hurt to implement that. For sure, it's interesting concept. Then we have comparing. We can get an absolute path. We can add. And that doesn't have a description, but I guess it's the same just as a slash. Oh, look at that. It takes var path. So it just isn't returning a new path. It's literally modifying one in place. Okay. Add file extension. So returns a new path with the added file extension. Okay. And extension should be given without deleting period, because some file systems may use different character. Although I know of none such beast. That's true. I don't know of any either. That's usually the extension is like a convention to just suggest what the type is of the file. It's not really necessary. Okay. Change file extension. Great. Expand tilde. Okay. So if we do tilde slash, we'll basically, use the get home directory. That's awesome. That's very awesome. extract file name, get current directory, returns the current working directory, as in where the build binary is run. So the path returned is the by this prog is determined at runtime. Okay, cool. So this doesn't take any arguments. Okay, it just returns the path. Checking if it's absolute, if it's relative to the base. Okay. Is it a root directory? Last path part to normalize path or executable. Interesting. Path and all getting a parent, getting relative path. Okay. Splits a file name into directory, name, and extension tuple. Oh, that's very handy because it's very happy, very handy. Split file into head and tail. Okay. Just tail and just a bunch of other things. And even iterator parent directories walks over all parent directories of a given path. Oh, that's very nice. Okay. So it's a small little module, but very handy. And it forces us to just operate strictly on paths. Makes sure that we don't put in random string by accident. We just need to handle first and provides ways to normalize it, right? Was it there? Normalize path. It just doesn't have any description, which is a little bit surprising, but it should. Let's actually try it. Normalize path, right? So let's say that beyond all that, we're just gonna make a path. Let test path is, we'll do something like slash user slash dot dot slash here slash dot slash dot dot slash, or I'll just be slash echo slash dot dot slash dragons. Okay, just something with lots of those dots, I guess, for now. So I could do let normalized path is, let's just do dot path. Okay, and then we're gonna do the test path dot normalize path. Whoops, normalize path. Okay, and what else? Echo, and we do test path, comma, let's just draw an arrow, and we'll have the normalized path. So let's see if we run that. Oh, normalize path for type paths. Normalize path. Oh, a variable path. Okay, so that normalizes it in place. That's surprising. So I guess we'll just do test path is this, and then we do var normalized path is test path. This way we're gonna copy it, I presume, right? And then we can just call the test path normalize, and let's see if that works. No, so we need to do, I guess, normalize path var. Oh, we just do normalize path. Normalize path. Now it's gonna work. Yes. No. Didn't. Exception. Oh, because we assigned this to this. String, normalized path. Expected 1 of first mismatch. It doesn't like something here. Doesn't like to be echoed. Can I just do that? Nope. Okay, give me a moment. I'll be right back. Need a short little break. Okay, I am back. Alrighty, so we have the error echo normalized path. It's as if we couldn't print out the path. Can we just do test path? Will that work? Is there something wrong with normalized path? Nope. So how do we print out those? Because I guess this doesn't work, right? Because I tried it already. Yep. Let's take a look at our documentation of paths again. All the normalization, iterators, get current directory now. Let's search nym lang path to string. Converting path to string. Yeah, you can't print it, right? If I define it myself, it works. Path string is path.string. People use it without thinking, could be weak in abstraction. Okay, so basically we do dot string. Was it provided nowhere? Oh, we just converted directly, like dot string, just so we converted into the. I see. Okay, that makes sense. So we do test path dot string and this is .string. And we should be able to go for it. There we go. Let's normalize, convert this whole thing into this thing. Perfect. We're happy to have those implemented. No need to fiddle with it myself. Very, very like it. Okay. So we went through paths, but what else do we have available? In NIM standard library, we had our paths, and we have directories, directory handling. There we go. So how does it work here? So basically procedure create directory, okay, and it has write directory effect, read directory effect, all those little things that we could, I guess, propagate, or maybe they propagate automatically. I am not sure. It can raise OS error or IO error. Okay. So it creates a directory, may contain several subdirectories. Okay. It does not fail if the directory already exists. Okay. That's good enough. We don't need to worry that all already existed. If it already exists, that's great. And I guess we have separate exists or create directory. Yeah, there we go. Okay, create directory, directory exists or create directory, move directory, remove directory, set current directory. Okay, sets the current working directory. Okay. And walk directory walks over the directory and yields for each directory or file in a directory. The component type and full path for each item are returned. Okay, a tuple of path component and path. Alrighty, so that's something we could look at because that sounds like something that will be well done. So let me put it aside and let's just start writing those things down. So let's go to colon fs and let's do like that. NIM standard library, and we have create directory with the directory path, right? And then we have there exists. That's how we check if it exists. Okay. And we have exists or create. Simple enough, right? I like it. We have move directory, source and destination, just paths. Okay, symlinks are not followed. If this fails, OS error is raised. This would be something very nice because it means that the user of the library, our library, if it would provide that functionality, doesn't need to worry about doing things manually. If they can make sure that, you know, we're not moving something somewhere where conflicts would happen, which in just moving directory there shouldn't be. So that's great. We would just need to define edge cases. What if we want to move directory from source to destination while destination already exists? What happens then? Okay. We have remove directory. And we do directory, comma, check directory. Okay. Removes the directory, including all subdirectories and files in directory recursively. If this fails, error is raised. This does not fail if the directory never existed in the first place. Okay, makes sense. Makes sense. So that's good. And then we have set current directory. Sets the current working directory. I am not sure about that one because we want to just have file operations that we provide specific paths to, okay? if we suddenly have set current directory or whatnot, I mean, it could work just per file directory. I mean, per file system that we created. Then it makes sense, where all those path prefixes are automatically set. But at the same time, it could confuse some users with, like get current directory procedure. It would need to be called on a specific file system, and only then it would actually make any sense. Would make sense when called on the specific file system as a helper to prefix future operations. But again, I wonder if that could complicate things. Because let's say that we do the create directory. We just create a directory, so we operate on a directory just with a file path, I guess. But what if we create a file or open a file? Do we want to have a concept of a file where we get some kind of handle to it, where we call open a file, and then we do something with it, and then close? I don't know. It's interesting with this set current directory. I guess we can start without it and then extend it, and that would means that we also have to have the get current directory that we call only on the specific file system. Could work. So we could do file system set current directory, and we give it directory and whatnot, and later in the future we can do file system dot get current directory. This way we could have various different current directories per created file systems. So that is interesting because, as we have as an example here, where we say file system is new real file system, right? In theory, we could do something like fs dot set current directory to specify it to some path, right? And do operations on it. But what we could also do is, if we wanted to specify the same set of operations, let's say in many multiple folders, we could just do, make something a little bit crazier. Let's say that, let's say that we have var of directories. Okay, directories, which is a new sequence of what we call it, I don't know, /user or .path, comma, what else would we have? Bin .path, and maybe one more, which will be var / I don't know, whatever, and .path. Okay, so we have those directories as a variable, and then we can basically say var file systems, and that would be equal to, and can we actually return the value from 4 or something? I don't know, but right now let's just consider that we have those file systems, and that will be we could probably do something like directories, right? And don't we have map? No, let's just say a new real file system. Okay, we'll call it 3 times for now. I don't want to go over looping, so we create 3 file systems. And then we do for I comma directory in directories, or sure, we can just do file systems and whichever. So we get the specific file system, set current directory. Okay, and specify the directory. Okay, and this way, right now we have 3 kind of pointers at file system, at existing single file system, and then we can do operations on all 3 of them. For example, if we do something and do a bunch of operations one by one, 100% possible. This way we don't need to worry about calculating paths every time or whatnot. We just have them already prefixed for each of the file systems. Yeah, I kind of like it. It's a fun idea. So let's stick to it. Okay. I'll get rid of this because we don't want it anymore. So yeah, set current directory and get current directory for a specific file system. I like it. And then we have the iterator walk directory. So it returns a path component and all that. So sure, iterator walk directory. I like it. These will be our directory operations. Walk directory recursively walks over the directory and yields for each file in directory. Relative check directory, skip special are explained in walk directory for iterator. Walking is recursive. So I guess we go deeper and deeper and deeper into subdirectories. So hey, that is very helpful. So iterator walk directly recursively. That sounds like something that will be relatively easy to implement for in memory. Move directory, remove it. This is just a pointer in our file system. Walking directories and recursively, all that could be implemented for also like FTP or whatever, S3 buckets. I can see it being possible. So far so good. Sure. So that's it when it comes to the directories module. So let's look at another one. Distros, I don't think we won't worry about that. Dynamic libraries, variables, files. Perfect. So what about files? This module implements file handling. Imports paths and OS files. We'll look at OS files later, sure. So, okay, basic things. File exists. I'll keep writing. File exists. I will just give it the file name. It says yes or no. Okay. Side effects and stuff. We don't worry about it so far. Okay. Directories, device files, named pipes, and sockets return false. Okay. I don't care too much about that. Then we have move file. Move file. Also simple. Source, destination. That's exactly like here. Remove file. And we have which file. It's just, this one says file. Well, this one says file name. Little discrepancy. Could be fixed. So we have move file, remove file, and that's it. Nothing else. So I guess we don't have get file here or open or anything. I guess we'll need to check that somewhere else. Maybe that's here in the OS files. We have tabs, copy flag, file permissions, and then we have copy file. Oh, okay. This is where we go to OS files. It's interesting how it's divided. So I have copy flag, symlink as is, symlink follow, symlink ignore. So this means that we need to deal with symlinks here. I'd say we ignore that here, because if we're dealing with something else, this is something that could be specified globally for the file system, per file system. When we create the file system, we could optionally give a value like that, okay? So let's say when creating a file system, we could specify additional config like copy flag or symlinks, okay? This way, when we create file system, we'll say that, hey, ignore all symlinks, okay? And that's how all the operations on files will happen. If you don't specify it, I guess that would default or something. File permissions, maybe we could figure out just a simplified generic version of it, because if somebody wants to go really deep into the specific implementations, they can use the specific, actual file system directly. But for simplified usage, unified usage, we would just have, can write, can read, can execute, or whatever, something that can be set. I don't know, that's something we can delve deeper into, I guess. The file access permission. So let's do, what about file access permissions? And let's give a link to these OS files, okay? But then we have what? Actual procedures, which is copy file, okay? Source, destination, we have options. And that's where we specify the symlink follow. So we shouldn't have to specify that, because this is to be used, universally, depending on it wouldn't make sense if we're suddenly writing to a memory file or in memory file system, or to something like I don't know, S3 bucket. I don't think that has symlinks. And I've worked with symlinks in the first place. For non-Windows OS's, options specify the way file is copied by default. Yeah, so for Windows is that, for something else. Yeah. Copy file to directory. Copies a file source into directory which must exist. That's an interesting one. So what's the difference between one and the other? Copies a file from source to destination, when destination.parent directory must exist. So I guess copy file to directory is just file to directory, source, directory. So with copy file, we specify the file name as well, while with copy file to directory doesn't change the file name. So we don't have to specify it, append it to the thing. And not necessarily that much needed. I can see it as being implemented already as some kind of helper that just utilizes the copy file. And if somebody wants to override it, they can, but they don't have to, because it has default implementation. Okay. Copy file with permissions. Copies file from source to destination, preserving file permissions. So the others, I guess, don't preserve it. Copy file with permissions. Interesting. So we have ignore permissions or permission errors. Okay. It's something to read up on. And then we have finally things like get file permissions, move file. So not copy, just move as well. Remove file, set file permissions. Okay, and that's where we specify the specific we specify a set of file permissions. Okay, I see. Makes sense. Try remove file. Okay, so we have try remove file. That just returns a bool, and that's it. Okay, but we still don't have a way of opening file and writing to it. So I guess we'll get there. Memfile support for memory mapped files, POSIX Mmax on the different operating system. I don't think we need to worry about that. And then we have OS, that the Drunken Alcoholic suggested. By the way, Drunken Alcoholic was writing in a YouTube live stream chat, so if there's confusion why I'm referring to him, and you don't see it in the chat on the screen or on Twitch, that's why, because I display only chat from Twitch as an overlay. So let's look at the OS. So this module contains basic operating system facilities like retrieving environment variables, working with directories, running shell commands, etc. Okay. Look at the paths, OS procedure, you write distros. Okay. We'll look at the streams again at some point, because it could be interesting to be able to also utilize some streams when dealing with files. Okay, so it has other OS files, OS directories. That's a new one that we haven't seen. Separators, vars, errors. So let's expand a little bit more so we can see what's inside here. Hard links exclude file permissions. Convenience procedure for set file permissions. And okay, I guess the only difference is that you don't have to import it. I don't know. Interesting. Execute shell command. What happened here? Okay. So it's like shell expand file name. What's that for? Returns the full episode path. Okay, so we don't worry about that. Expand tilde. I don't like that suddenly this is for strings, while on the other stuff we're dealing with paths. I guess maybe this just hasn't been reworked yet. Same thing with expand tilde. File newer returns true if the file A is newer than file B. Okay, so this would be more interesting if get last modification time, get last access time, get last modification time, get last access time, and get creation time. That could be interesting for both files and directories, although I don't know if it's possible for directories. Probably depends on file system and whatnot. File newer, sure. Find X, we don't worry about that. Get a file name, creation time, get current compiler, executable, process ID, get file info. That's what I'm interested in. Retrieves file information for the object. Get file info. And what is file info? File info gives us the ID, which is the device ID and file ID. Okay. The kind, which is path component. Path component is file, link to file, directory, link to directory. Okay, so basically it defines what that is. The size, permissions, link to count, last access time, last write time, creation time, block size, and is special. In Unix, some files can be special and non-regular, like FIFOs, devices, and all that stuff. Okay. So let me just actually copy that and just paste it here as a reference because we're collecting kind of like reference. Okay. Just paste it there. So get file info could, in other words, replace the get creation time, get last access time, all that stuff, because this sounds, although sounds like just some sugar. So let's actually place them here, just indented, okay? Because get file info already gives all that. Okay. So we're going back to you get file info. We have two of those. Also, we can provide either file or file handle. Interesting. And the file itself is pointer to C file. Okay, the type representing file handle. Okay, and file handle is also integer. Okay, so this is more of internal stuff. Okay, get file info again. Get file size, so that will be the same thing. Get file size. Get access time again. Get last modification time. File permission is admin, is hidden. Where are we here? I'll be a little bit faster. Just checking if the file is valid. All those things that we don't have to worry too much about. Same file content returns true if both path name arguments refer to files with identical binary content. I don't think we need to implement that. And that's it. Just a little bit of sleep and that's it. Huh. An exists file is deprecated. Use file exists. Yeah. Same thing with exists directory. And that's like templates, huh? Okay. All right. Okay. OS paths 2. What is OS paths 2? Standard private OS paths 2. I guess we don't worry about that. So that's not something. And OS directories, copies directory, copy with permissions. All that exists here, but it's private. So how do I use it? OS common? That's again private. Not sure, but it would be nice to be able to copy directories and create directories, all that, right? So let's just use it as an example of how it should be done, because we have create directory, we have move it, but we should have copy directory, right? Source and destination. Copy with permissions, I guess. And create, we already have that. Exist or create, yes. Move directory, remove, set current directory. So we have all that. And walking in those two ways. We have walk directory. Then we have walk directory recursive and walk directories. Iterate over all the directories that match the pattern. Okay, so we don't worry about that. Walk files. Iterate over all the files that match the pattern. And walk pattern. Okay, so we don't worry about that. Okay, it's getting us somewhere. So we went through all that. We have math libraries, internet protocol, threading, parsers, documentation utilities, generators, hashing, serialization, miscellaneous. Doesn't seem like there's something of interest here. Modules for the JavaScript backend, impure libraries. So the ones up there were pure, whatever that means. These are impure. Procedures and operators for handling regular expressions, many help database. For reading user input from standard wrappers, Windows specific, Unix specific. Okay. Regular expressions, database support, and network. Okay, so that's it when it comes to NIM standard library. Okay. Hey, it's an interesting start. I like it so far. We have decent set of things that we should be able to define. But now, how does it compare? Oh, let's just go to streams just in case. So we have open input stream and all that, file stream example, write and read. So we could add something like new file stream. Okay, and then we have the path and the read/write thing. Okay. And then we could be able to call like write line or probably write or some other stuff. Read, I guess. Read line and whatever else would be available there. Okay, I can see that to, being possible. Okay. But nonetheless, it would be nice to be able to maybe not open a file not open a file and just keep it open so that it's writable for the time being, but it will be nice to be able to do something like read file and get the whole contents of it, right? As, I don't know, string or binary or whatever it should be. And write file and maybe overwrite file. Something, probably options here. Write / append / overwrite. Okay. Can read, write, and then you have move, remove, all that is already defined. So, yeah, something like that. Makes sense. So let's look at Afero, how they did that, because we have one side of the coin. But let's look how something that was designed for dealing with various, like new memory map file system, new OS file system. Oh, like one is OS, one is memory mapped. Okay, that's a little bit nicer naming than real file system and in memory file system. Okay, I like it. Yeah, usually like you would use this. You can open. Well, before I had OS open here, just do appfs open. Okay, so it tries to do things the way Go would do. So let's see, file system methods available. Okay, so it has change mod, whatever you call it, change own, and change times. Okay, so this is more of a Linux approach, which I personally like. Create, make directory all. Okay. Oh, I guess that this one just makes a specific directory. Well, this one can make the specific directory by making all the ones in between that need to be added. Okay. Name? Open file. What's the difference between those? I guess one is with permissions. Okay, remove all, rename, and stat. Let's copy it and let's just add it somewhere here, and we'll just call it goes Afero library. Okay. We just paste it here. And we've got something. And then file interfaces and methods available. Closer, reader add, seeker, writer, and writer adds. So we have name, read directory name, stat sync, truncate, write string. So this is for file stuff. This will be for fs as a file system. Then we do for file. Read directory names. How is that for a file? Okay. And using Afero's utility functions, checking if directory exists, contains bytes. Yeah, read directory. Huh? It returns file info. Oh, list of file infos. Okay. And walking, all that. Okay, sure. So be generic. Okay. Makes sense. And then calling that. Okay, makes sense. And it implements it for OSFS, memory map, file system, SFTP, GCSF, which is Google Cloud Storage. There we go. Base filtering backends. Okay. Read-only file system. Look at that. So, yeah, when you try to create, it will just say nope. Regexfs. Huh. Regular expressions. Some other backends, cache and read. Oh, okay, so it extends by adding cache and other things. Copy and write. And it would be nice to add SSH and S3. Okay, I see. But we don't need to read those details here. All we care about right now is all that. So I guess we should take more of an, approach that Nim already takes and stick with that, right? The only thing will be to just add some things that were missing from Afero. Let's see. To make sure that an open file, things like that works. Rename is kind of nice to not just do the whole move or copy or something, because it's moved to the same folder, but just with a different file name. Stat is just the same as our, what was it? Get file info. Okay. And we have name. I guess that just returns file name because this is for a file. So file name, read directory. I guess we could read directory that's the file is in. Vector name, stat, sync, whatever sync is. Truncate and write string. Okay, sync, I guess, could be something like update the file information if working with something like FTP to check if something updated or not yet. That's an interesting concept, because for a normal file system, we'll be like, okay, done, updated, nothing else. Or, it just reloads the size of the file and stuff. So it still makes sense, but it makes more sense if we're doing something else. I really like that. Although I don't know if it makes sense. Do we cache all this information or we call it like methods? It's another interesting idea. Then the sync thing doesn't make sense. Unless some implementation of the file system could say that, hey, when you're running that, cache the values instead of checking them every time, and then sync will refresh them, actually refresh them. Interesting concept. And they can write string, okay, all that. Directory exists. So let's quickly check how did that tutorial, that one tutorial for nim actually specify reading and writing from a file. And again, nimlang.org documentation, and there was nim basics tutorial, and we had, was it here? No, it wasn't here. It was the other one. NIM by example, right? There we go. Files. So we had read file available, just like that. And that's like pre-imported. And it returns, I guess, a string. We have read, we can open a file here. And that will probably return a file on which we can call readLine. Let's figure that out. If I'll copy this thing, what will it tell us? Let's go here, let's paste it. And this will be a file. So what is open? Sync.io open. Ah. Can I get to the documentation? Open the whole sync.io. Opens a file named file name with given mode. Okay. Sync.io. Free open. Oh, reopen. Okay. Default is read only. I'll return a file. What is a file? A file is specified, like we saw somewhere else, pointer to a C file. And a C file imports C stuff. Okay, so it's more of a just handle to a file, I guess. And then on that file, we can specify more things. Okay, so it's the position of the file pointer. Okay, this is a little bit more low level. And I guess this is not something we will be able to operate on when dealing with FTP, for example. Okay, no big deal. We don't want to be worried about implementing those low-level things. We just want something simple to operate on. Somebody wants to work with, gigantic files, then they can, work with particular thing, because then it's beyond what we want to do with our library. Okay, makes sense. Get file position, size, all that is available here. And specific implementation for Windows and such. So let's look up sync.io in the documentation. Let's just open file. And we can write and do that. Okay, makes sense. So we go to the standard library. Sync.io. Do we have something like that anywhere here? Sync.io, very synchronized I/O operations. There we go. One thing that we missed, we defined a file handle and whatnot. The modes for the file. Okay. Read, write existing. Open the file for read and write access. If file does not exist, it will not be created. Okay. And append. Okay, sure. We could easily make it so that those different types are respected when implementing, something like FTP, where, something happens. If, let's say, there's a situation where FTP doesn't allow to append to a file, the operation suddenly would mean either we could make, whoever makes the library makes it that, it throws an exception or something, or it simply does sound like, hey, download the whole file, append to it, and send it to replace it, just to make it work with the whole thing. Okay. Yeah, the seek position and whatnot. Then we have a bunch of variables. And we close file and check to if it's an end file, flush file, get file handle, position, file size, OS file handle, open, read all, read buffer, read bytes. Okay, there we go. So we could, because I want to check, when we download a file, what is the actual type of data that we want to return. Because let's say we're working with a file system, of OS file system, we might have binary file. We want to get a buffer or bytes or something, while we on some other time we want to just get a string or something. And the same thing goes for FTP or S3 bucket. We might be working with different files. So let's see, read all just returns a string. Read buffer, we give it the buffer, which is a pointer and the length. Okay. All right. And reads len bytes into the buffer. Excuse me. The buffer pointed the buffer returns the actual number of bytes that have been read, which may be less in length. So I guess the buffer is bytes? I don't know, because nothing is specifying what the actual buffer is. What is just pointer? Pointer, built-in pointer type, use the address operator to get pointer to a variable. I don't know, maybe nym does some magic. Who knows? Okay, read buffer, read bytes. So let's write those down quickly so that we have some idea of how to deal with those. Let's go to common FS, and let's go here for file operations. We can go with something like, wait, not here. Here. We can have read all, and it returns a string. So that's one convention. Read buffer, which returns an integer, how many bytes have been read. Read bytes, to which we provide an array, open array. We need to learn what open array actually is. Start length, and again, I guess number of bytes that have been written. And read character, it literally reads one character, interesting. And read characters, and how many, I guess? No, just all of them, okay. Read characters with start length. I don't know if we'll be implementing all of them. And read file, which also returns just a string. Opens a file name, this reading calls read all, and closes the file afterwards. Okay, sure. And then we have read line. And okay, this is just to modify the line instead of getting this one, read line, so just returns a sequence of strings. And reopens the file with given file name and mode. It's often used to redirect the standard in. We don't worry about that. Okay, and then we have write. Bunch of different forms for a write. We could write in a way that echo works. We would give it a file and just var args of string. Okay. So we can just continue it here. We can write a bool to a file. I guess this is simple bit. That will be, I guess, possible. Write a character. Write a C string. Okay, this is getting complicated. A lot of things to implement for somebody that wants to work with the library. But we'll shave it down. We'll shave off most of them, I guess. And then biggest float, I guess, just biggest float available. Interesting. And just a bunch of those, whatever. I'll just copy paste everything. Why not? And we've got that. And then we have write buffer. Okay, so that's similar approach to the other one. Write bytes again. Same thing as when reading. And then what else? Write characters. Yep. And write file as in just contents of the string. Opens and closes it. Okay. Or just array of bytes. And we have write line. And we can provide many lines. Okay. Makes sense. Oh, that's lots of copy and pasting. So instead of writing code today, we're just figuring out what to do. Okay. Iterators. We can iterate over lines. I'll write it down as well because it's just helpful. More of lines. What's the difference here? One is file name, one is actual file. Okay. And then we have just templates, which are just write and all that stuff. Okay. Okay. So we just have template for this. We have template for reading all the lines. And standard message template, which expands to either standard out of standard error. We don't worry about that. Okay. This feels like it's been productive. Okay. All right. I like it. So if we have all those bunch of different writes and bunch of different reads, how does Afero compare to it? Let's see. We open a file, we get the file, and the same thing here. So that's just opening it. And for the file, we have reader, reader at, seeker, writer, and writer at. Okay. So these implementations apparently allow to read it and write or at specific points or seek through the file to read it, I guess, and write at. Let's look at that whole seekers and stuff. Because we had it specified here, we just don't have it shown here. So let's, for a complete list, go to Afero's Go doc. Why not? Let's look more at their documentation. So we have constants. Okay, different errors. And whatever those are, file separators and whatnot. What else? Variables. And then we have all those functions to check. Oh, there's plenty here, like glob. That's interesting to match something. Yeah. Hell yeah. Do we have it here, glob? No. Let's paste it in. Okay. Let's just straight up copy it. Why not? Because this is more than we had here, right? So we just paste it here and there we go. Then type Afero. So that should be pretty much the same thing. It's just when we call it on the Afero thing itself, because in nim we can call, same function in so many different ways. While in Go, you need to specify a separate one when you call it on a file system, a separate one if you're calling from Afero, and something else. So, oops. So, you need to do some gymnastics, and then you don't have to, which is awesome. Type base path file name, read directory. We have paths done. Base path file system. Okay. That's a little bit confusing, but I guess that's it. And we have suddenly all those create, else, stat if possible. Okay, real path, remove. So I'll copy that again because this is what we can do with the file system, right? So we just paste it here. Make sure it's like that, and we'll use it as a reference. Cache on read. Okay, so different types like cache on read, cache on write. They have their own little limited versions, I guess. We have the file temp file from IOFS. We don't worry about all those. New base path file system, new cache on read. Okay, no big deal. HTTP file system, I guess their implementation. Okay, we don't worry about all those various implementations. I want to get to something more specific. Read only, regex, all those types. Okay, that's it. What is the whole reader thing then? Jump to reader. Afero write reader. And write reader. Function write reader. Path string. And IO reader. Oh, IO reader is like the normal Go thingy that allows to read. Okay. So we don't worry about that. We can think of it, I guess, with those readers and stuff as that could be a fun concept, because we have this whole file stream and string stream that have those basic implementations. What if we would have a little bit more generic reader implementation that can take an array of something and iterate over it in a lazy manner, like an iterator rather than something else? Yeah, I'm wondering if I'm getting ahead of myself a little bit here. But if we get back to the code, what if when you call, for example, instead of doing read all on a file, you get your file with open something, right? And you just do get reader, where you can specify what kind of reader, or just get reader, and then from that reader you can specify, read buffer or read bytes or whatever, and that is an iterator that you can iterate over those multiple characters or something, like characters, or you want to go through sequences of 10 strings or something. And this way it could be implemented in a lazy way, like streams where the data is coming in and it just processes it. Or the implementation of the actual implementation of the interface would say, hey, I actually need to download the whole thing, because I know that's how FTP works. You need to download the whole thing first before you can do something about it. And that will be, taken care of by the actual implementation of the interface. So let's note it down somewhere here. A concept of a reader/writer, where one can request, get a reader or get it for a file. That reader then can return an iterator that acts a bit like a stream of, characters, bytes, bits, sets of bytes, lines, and whatnot. So we would be able to have something like a reader object or something, and from that object we'll be able to basically, how would you describe it? From that for that specific object, one could implement how to actually go over those specific chunks. So let's say by default there will be one to read lines, one to read something else, and something else. And the implementation of the actual implementation of the, either memory file system or something else would be able to take care of, fetching those parts of it or not, or something of that of something of that sort. Interesting idea, I'd say. So we have a bunch of existing implementation for, I don't know, lines, for something else, and we would just need to have a generic way of requesting some kind of chunk of data that then we can convert to the specific something. I'd say it would be difficult to implement. I'd say let's focus less on that we could add that later, but for now, if we would be able to do something like write file and we just give it the string or the whole array of bytes or something, those two things where you just dump the whole thing, we'll call it date. That will be one thing. The same will be for reader. Maybe later we can do something like something that supports streams. And at that point, we should learn enough about how we write things in NIM to actually get to the point where we can make some more decisions. Okay. So I'll be finishing the stream very shortly. So I'm very happy that we were able to, get some idea. Maybe I'll just quickly rename the realfs to oops, what the hell just happened? I used Control R, my habit from IntelliJ IDEA, kind of. IDE. So let's get back here, and we wanted to replace realfs with OSFS, okay? As an operating system file system. And in memoryfs, it can stay here, okay? So here, instead of having the file realfs, let's just rename it to OSFS, and here the same name, OSFS. Okay, cool. And the only thing to change is hello, where we need to change this into OS and new OSFS. Okay, so to finish off my thoughts, next stream, maybe we'll be able to decide what we actually want to implement, which from what, and start creating interface, and maybe an implementation for that interface when it comes to OS file system, and see if that works. That will be some interesting way to learn the NIM language. So that's the idea. So thank you for watching. Please, if you liked the stream, subscribe, like it, comment, and see you next time on Wednesday. Thank you for watching.